Okay, still in section 5.3, the definite integral, and we went over definite integral rules in the last video. We're going to use them in example 82, make sure we understand all the definite integral rules. Again, I have not told you how to actually evaluate these definite integrals yet. I've actually just said to you, hey, these are going to be a lot easier to evaluate than doing those Riemann sums we did, right? The sum of all these rectangles and then taking the limit as a number of them goes to infinity. But okay, so we're just using the rules right now. So assume that we have a function f of x, and the area under the curve between x equals 1 and x equals 9 comes out to be minus 1. Now remember, that seems weird, area is minus. This is a net signed area. So if any value of the function lies below the x-axis, then the area between the function and the x-axis would be a negative area, right? Because the height is f of x, which is a negative value, so height times width to be negative. So that's why you get negative values for integrals, because some of the function lies below the x-axis. I just want to make sure I pointed that out in a video. All right. And then let's say the integral from 7 to 9 of that same function is 5. The area under f of x between 7 and 9, when I say under, it means between the x-axis and the function f of x. If some of it lies below the x-axis, it could be negative again. But the total area between 7 and 9 comes out to be 5. And then the total area between x equals 7 and x equals 9 of h of x dx, so the definite integral of h of x dx from 7 to 9 is 4. So we have two functions we're talking about, f of x and h of x, and we want to go through and look at their properties. Okay, so I'm going to keep that there. Okay, so let's say we want the integral from 1 to 9 of minus 2 times f of x dx. So this is the property where I can bring a constant out in front. I put the minus 2 out in front. Then I have minus 2 times the integral from 1 to 9 of f of x dx. We know that the integral from 1 to 9 of f of x dx is minus 1. So this is minus 2 times minus 1, which is 2. The integral from 7 to 9 of f of x plus h of x dx. Well, one of the properties is if we're adding two functions, we can break it up into two integrals. So that's the integral from 7 to 9 of f of x dx plus the integral from 7 to 9 of h of x dx. Which if I look up, those values are 5 and 4. So that's 5 plus 4, which is 9. So now I'm going to kind of use the same property, but also I'm going to do constant in front at the same time. So I have the integral of 2 f of x minus 3h of x from 7 to 9. So I can break it up into the integral of 2f of x and at the same time pull out a constant 2. So it's 2 times the integral from 7 to 9 of f of x dx. Then I have minus 3h of x, and I can bring out the minus 3, then times the integral from 7 to 9 of h of x dx. I again know that this guy is 5 and this guy is 4, so it's 2 times 5 minus 3 times 4 comes out to be minus 2. Now in part D, I want the integral from 9 to 1 of f of x dx. So that's going to be the opposite of the integral from 1 to 9 of f of x dx. So it's the opposite of the integral from 1 to 9 of f of x dx, which is minus a minus 1 or 1. Now let's say I want the integral from 1 to 7 of f of x dx. Now I don't have the integral from 1 to 7 anywhere, okay? I have the integral from 1 to 9 and then from 7 to 9, so I can figure out the integral from 1 to 9 and subtract what's in from 7 to 9, and that would leave me left over from 1 to 7. So the integral from 1 to 7 is integral from 1 to 9 of f of x dx minus the integral from 7 to 9 of f of x dx. That would leave you the integral from 1 to 7 of f of x dx. So that's minus 1, minus 5, which is minus 6. Okay, now I want the integral from 9 to 7 of h of x minus f of x. So I don't have integral from 9 to 7 anywhere, but I have 7 to 9. So I take the opposite of it first, from 7 to 9 of h of x minus f of x dx. Minus, now I can break this up into two integrals, so minus the integral from 7 to 9 of h of x dx, then minus a minus, or plus the integral from 7 to 9 of f of x dx. So that becomes minus 4 plus 5 equals 1.